I don't mind. I just want people to be educated. I wrote 2 very comprehensive articles about vegetarianism in my Chek report. So if you're interested, you can contact the Institute and find out about that. But I addressed all the dogma and completely obliterated a lot of the common stuff with fact and knowledge. So let's have a quick look here. Here are some of the microorganisms in the soil. That's a fungal feeding nematode. A nematode's a worm. This little worm feeds on the fungi. Fungi are super high in vitamins, super high in protein. So when this guy eats the fungi, not only does he poop out nutrition for the plants that the roots can suck up, but when he dies, he leaves his carcass behind and the plant roots can suck that up and the other microorganisms eat him, okay? So he's a key player. Here's a protozoa. There's just billions of these things down there, and they eat other little protozoa, and they eat other things that are smaller than them, other viral and bacterial and fungal organisms. Here's a predatory nematode. This is a worm that hunts other worms, right? This one feeds on fungus, and this one feeds on that one, okay? I told you, it's really badass down there. There's a lot of serious stuff going on. You don't want to shrink yourself down without at least an M16. Okay? And then below it all are bacteria, and there's just gazillions of bacteria of all different types, but the balance of the bacteria in the soil has a lot to do with how the farmers manage the soil, and just like you have to have about 85% friendly bacteria to 15% unfriendly bacteria in your gut, if you don't have that ratio, you start producing all kinds of toxins. It starts to poison your body. Your bowel movements become irregular. And I could sit here and list about 20 other things that will happen, other than the fact that it'll be very dangerous to walk in the toilet behind you. But the same thing's going on in the soil, exactly. Okay? And what's going on in human beings' intestinal tracts right now matches what's going on in the soil. So what are some of the things that humus, these microorganisms in the organic matter, do for us? Well, humus is, like, for example, when plants die in the winter time, in the fall, when the fruit falls on the ground that doesn't get eaten, when an animal dies, when a bird poops as it's flying by. Hope it doesn't get you. I've got hit in the head twice. Supposed to be good luck. Of course, I had hair before that. Okay. So I don't know if it was good luck, but they say grass doesn't grow on a busy street. So humus has a crumb-like structure. So when the microorganisms eat up the dead leaves and the dead grass and the dead stuff, it produces a crumb-like structure. Like if you take a graham cracker and break it up, that's a crumb-like structure. That allows air, oxygen, to pass through the soil to allow oxygenation of the soil so the aerobic functions in the soil can happen. Just like you have to have aerobic metabolism, so does the soil microorganisms. There's millions of aerobic metabolic functions going on in the soil, but if the soil becomes too packed because there's not enough organic matter, you get soil erosion and water wastage because the water runs off like crazy. It might interest you to know that 1 square foot of humus can hold 7 gallons of water. This stops soil erosion and helps regulate soil temperature, because holding on to water is what helps regulate soil temperature, so that the soil temperature maintains a fairly constant level. Otherwise, organisms in the soil will die, and if the soil gets too cold in the wintertime, then the root structures freeze and all the plants die. Okay? So we have temperature regulation. By the way, the crumb structure, this is interesting. Research shows that when the microorganisms metabolize the humus and create the crumb structure in the humus, each little piece of soil acts like an electromagnetic antenna. So just like you got the little round dishes on your hotels and your houses to suck in the satellite signals, the microorganisms create billions of little miniature satellite dishes that sucks in cosmic energy from the sun, from the moon, from the stars. And I'll show you later how that charges up the soil, and I'll show you how plants are actually electronically driven, just like human cells. It provides much of a plant's immune system. These guys actually protect the plant, and they all have favorite plants, and they protect those plants, and they fight and kill each other, and they feed the enemies to the plant. Okay? They feed on predators. Here is a predatory nematode. This is what's called this is a parasite nematode, so a parasite worm. And this one is, I believe, an eelworm that's trying to attack a cabbage plant. This comes from a book written by Lady Eve Balfour, who's the founder of organic farming as we know it. and this was published in 1942. It's called The Living Soil, this book. And she shows here, these are fungi, what are called symbiotic fungi, that actually share a working relationship with the roots of plants, and they create loops out of their bodies, and they excrete very powerful adhesives. And when the worm wiggles his way through, the adhesive sticks to his body, and then the fungi excretes very powerful acids. By the way, the fungi excrete acids so powerful they dissolve rock, and one of the things they do for the plants is they dissolve the rocks and they feed it to the plants in trade for drinking some of the plant sap, which is primarily carbohydrate, because they're carbohydrate lovers. So they swap sugar for minerals, okay, and for protein, because look here. See, there's his digestive tract and his nervous system. See that? But look down here. See all the filaments in there? That's the mycorrhiza. Those are the filaments of the fungus. It eats the predator from the inside out and feeds the organs and the nervous system first to the plant. Okay? So, like I told you, these suckers, these plants, they love steak. Now here you can see a photograph of the inside of a plant root, and these little hair-like structures are what are called hyphae, and that's the actual filaments of the fungus in the soil. 85% of all edible plants have a symbiotic relationship with fungi. So they're called mycorrhiza formers. Myco just means fungus, rhiza means filament. So 85% of the 350,000 plants that human beings can eat have this relationship. And look what they do. They suck nutrition up out of the soil and they store it in these little nodules right here. And that's how healthy plants make it through alterations in weathers. We get hot, dry spells, if we go without water for long periods of time, these organisms actually create little storage banks of nutrition for the plants in there. They have a very, very elaborate system they've developed over billions of years of evolution. Interestingly enough, here I am at a biodynamic farm, and my buddy Robert Farmer, who's a biodynamic farmer, was showing me the nodules. There you can actually see the nodules on the roots, okay? And when you split one open, it actually looks like blood inside. It's amazing. You can see the little picture right there. We split one of the mycorrhiza formers, nodules, open, and inside it looks just like human blood. And all that is nutrition in reserve for the plant to make sure it has the optimum, listen carefully, to make sure the plant has optimum opportunity to express its genetics and suppress its genetic weaknesses. Sound interesting, eh? Just like human beings. You don't eat right, you express your genetic weaknesses. You eat right, you express your strengths and suppress your weaknesses. Plants do the same thing. Eat sick plants, hey. Eat sick animals, there's not a vitamin in the world that'll help you. Microorganisms also liquefy minerals and convert non-organic compounds into organic compounds for the plants. These microorganisms produce amino acids, organic acids, and organometallic acids for the plants. 40 to 80% of the bacteria in a plant's rhizosphere, which means the sphere of its roots. Okay? A corn plant has about 20 to 26,000 miles of roots. One corn plant. Most people don't know that. Okay? Strung end to end, the root structure of one corn plant would go around the world. And that's called the rhizosphere. It's sphere of where it attracts things into the soil, and the sphere in which it has a relationship with microorganisms. 40 to 80% of the bacteria in a plant's rhizosphere produce vitamins. Soil microbes produce numerous vitamins. Everything you can find in a human body, by the way, is found within the rhizosphere of plants. Whatever enzymes, whatever vitamins, any nutritional factor that a doctor can find in you, I can show you soil research and agricultural research to prove to you that that same stuff exists right in the soil. And whatever's missing in you is probably what's missing in your diet. There's other factors involved, but in general, you see that for a fact. Okay? The soil bacteria and microorganisms produce numerous enzymes. They produce steroids and many other hormones, by the way. They produce anabolic steroids. They produce catabolic steroids. It's serious stuff down there. Okay? Whatever's going on. Remember what I said when I got that award this morning? As above, so below. I meant it.